First thing is as we know already the differences between a single linked list and double linked list where the two nodes, where the node has two connections left and right. Every node has two connections. One is a data and two are the connections. So how can we create that? First, whenever you are creating the node, you need to change the definition like define is double underscore init double underscore is a self. Of course, it will take the data, that element what you are inserting. Self to data is equal to data. Next one is self dot two links. Previous and next you can write, or simply left and right you can write. Left none and right none initially. Once it will create the node, then we can do the remaining operations. That is.
Sir, right. Self dot right.
Huh?
Self dot right. No, sir.
Yeah.
Left hand.
Yes. Sorry. Self dot left and self dot right equals to none. It's the same, we are starting with the head node. When you are creating that starting node is a head node is a null. That is also none. It's not pointing. So when you are creating the first node, is initially we have taken that head node equals to none. Head node equals to none. And when you are calling that method inside the class, when you define that method, suppose add or adding at the end, append. So when you are calling, you need to pass the data. So first we are creating that node. You can use that word is a new node or something. Creating the object by sending the value. So then what will happen? A node will be created like this. Node will be created with the given information at some location that initially will be stored into that variable is a new node. And once it is ready, that node is ready, we need to just check only connectivity. Here it is a suppose data is a 10, consider 10. Only that left and right always none. First we are checking that if that head node is a none, then simply we are storing or directly head equal to or head is none. Anything you can write. Into the head we are storing that new node address. New node. If not, see here is the first node. So we are placing that 1000 here. Is connecting to that one. Connecting. Suppose if nodes are there, just I'm taking the 2000 and that value is a consider 20. These connections I'll explain. 1000 is this one, 2000 and 1000. Now the thing is, suppose again they have called this method and passing that 30 to insert 30. So first step, we need to create the new node. We have to create the new node. Is a 1. Is a 3000. That is, that new node will be stored here. 3000 here. 3000 here. Next one, we are just checking if head equal to none. No, head is not none. Then what we have to do? We need to travel to that last location. We already know. Starting from the head, take one temp variable. Starting from the head, just repetition of loop while The temp to link, that is temp to next, is not none, is not equal to none. Just moving that into the temp, place that temp to next. 1000 to next is a 2000, it's not none. So 2000 will place, is pointing. 2000 to next is a none. So condition fail. Condition fail. So now you need to create two connections actually. Two connections. This is one connection and this is one connection. 2000 you need to place here. 3000 you need to place here. Easy. First 3000 you are placing here. Consider 3000 means new node is added to temp to next. Temp to next. Temp to next equal to new node. Nothing but 3000 will be added here. Now 2000 we need to store here. See, always we use a better next na. Use for confusion, right? Use always right because left and right. Left and right. Here also, just write a temp to right equal to new node. Temp to right equal to is a new node. Then new node to left equal to temp. Nothing but 2000 you need to place here. 2000. New node to left equal to temp. This is else. This is the way we are creating that append. So every node adding at the end. Every node adding at the end is a 1. Is a printing and as well as a counting is a both are same. Printing and counting is both are same. Like for example, if nodes are there, let me take some nodes. 1, 2, 3, 3, 4. Some nodes are there. Okay. Already that locations I'm giving 1000 is 2000, 3000, 4000 like this. Is it head node is holding the value? Better we write. I'll show you on head node. Is a 10? It's 2000. It's 20,000. It's 20. It's 3000. It's 2000. 30 is a 4000. Is a 40. Is a 3000. Is a none. The nodes will be like this. The two are same. No need to change. One is a suppose is a traverse is the function. Traverse. First we are checking that if head is none. Directly we can say that is an empty list. Empty list. If not, start using that temp starting from the head. We keep on checking that until the temp not equals to none. None, we keep on printing the temp data and moving that temp equal to temp to link. Temp to right is a 1. This is what traverse is what traverse. But suppose if they ask get length, get count or length or anything, then first we are declaring one variable count equal to 0. It's the same story again. Into temp, we are storing that head node. While that temp, directly you can use a temp also. Temp is not equal to none or temp. In two ways, I'm writing the code. Simply count value increase, count plus equal to 1 and temp equal to temp2 right. We keep on moving. Once loop execution completed, just simply return that count value. Traverse as well as a get count we are writing. While traverse, we need to display whether the list is empty or not. But in creation of a get count, see, suppose if no more, count will be 0. If data is there, count will not be 0. Some values are there. Now here, next one is a add first I'm writing. In add first, look at this. I'm just giving information only. Suppose this is the node we are creating. Node. This is for add first. I'm writing the logic. Suppose added one node 50. Initially, that value we are collecting into new node. We are collecting into new node. Node is ready. But now the question is, already it is pointing to this one. Remember that one. Two things we need to do. Right side, two connections. This is one connection. This is one connection. And this is one connection. Two connections. And left side is one connection. It is pointing to the first one. Is a 1. Okay. First I'll give the number so that I'll write the logic. This is one first connection, consider. Next one is a 2. And next one is a 3. Is a 3. 1, 2, 3. So first 1 I am writing. 1 means 1000 you need to place here. First, where is the 1000? 1000 is a head. Head you are storing into this location. Nothing but new node to write. New node to write equal to head. That is first. Second one is, see, arrow is pointing to this. Is it wrong? No? Reverse. This 5000 you need to place here so that it is pointing to this one. 5000. 5000 means new node. Look at this new node. You need to place head to left. Head is still 1000 only. So head to left, into that you need to place new node. It's a second one. Third one is what? That 5000 you need to place here. 5000 you need to place. New node will store into head. Into head what? New node will store. It's a third one. First, second, third. First, second, third. This is what? New node? New node left null because in the constructor in init by default a new one creating with the left null, none, right none. Na? So no need to place again. That's why. Okay, na? Now in the same way, this is, suppose if you want to create node after the specified node. If you want to create the node after the specified node. That is what add after. Add after. Suppose is a third location given. Is a third location given. Consider. Is add after. Now is a 50 I want to create here. 50 I want to create here. It's a new node is holding that 5000. And we already know same like a single linked list logic. First go to the target node. For this already we have written the logic. By taking one I variable while I is less than location, by checking the location valid or not. Up to here concept is the same. Only connections important. Here this side two connections. This side two connections is a 1 and is a 2. Is a first connection and is a second connection. And next, here also, two connections we are writing. This is one connection and this is one connection. Suppose I'm just giving 3 and 4. So one by one we are writing. For add after, what is the code we need to write? First step 1, look at this. This 4000 you need to store here. Sir, where is the 4000? Target to write is a 4000. Will be stored into node to write. 4000. Here, into new node to write, we should store target node to write. Is a first one. Second one is a, you need to store, this is very, very important. 5000 you need to store here in this location. 5000 is easy. It's a new node. But where you have to keep in this location, na, observe this. Target to right is a 4000. 4000 to left is this location. Left is this location. So target is 3000. That right is a 4000. That left is a location. Into that new node will store. Into that new node will store. Here 5000. Only this is important. Next remaining two easy. 3 is connection this. Nothing but 3000 you need to store here. 3000. 3000 means what? Is a target. Store into new node to left. New node to left equals to target. Is a target. Okay. The next one is a last one. This 5000 you need to keep here. Fourth one. 5000. New node will be stored into target to right. Target to right is equal to new node. Is a 4. Is a 4. This is the way we are creating the node after. Adding the node after the specified node. Adding the node after the specified node. That is okay. Just based on all these things, please write the logic for delete first and delete after also like the same thing and complete.